So, very good morning, students. So, welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and Mastermind Schools. So, once again, I welcome all the participant branches along with your class 6th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th. Today we are going to start new chapter, that is last chapter. Last chapter of our material, pressure. That is chapter number 7. Right, pressure. Of course, today we are in the session number 1. So far we completed all the concepts of 6 chapters, and today we are entering to the 7th and last chapter. So after completing this chapter, this is the syllabus for test 8, right? Test 8, which is to be conducted on 24th February. So after completing this chapter, we have the complete revision session for the grand test in the month of March. Okay. So this is the last chapter of the physics for class 6 students. And overall, there are 7 chapters. 6 we completed and the 7th one now. So during the revision time, we'll go for the practice of all the worksheets and everything. What else is there in the material? But first part, we are completing all the conceptual parts. So in that process, we are going to start the 7th chapter today, right? So pressure, you know the word. The word is very familiar for you because we'll use this word many times in our day-to-day life. Either it may be in school or it may be at home, or your parents may use, or your sisters, elders may use, because the pressure plays very important role. When you are reading also, when you are given more homework, you feel pressure, right? When you are playing anything for more time, you feel pressure. So anything will you do more, anything will do more, will feel the pressure in day-to-day word. But when you come to the part of physics, there is a pressure is a very big word, or it can give a lot of applications in our day-to-day life. In our entire life also, this pressure plays very important role. And the examples which we are going to discuss in today's class, we can observe in the many places in our day-to-day life. Such a wonderful and powerful word is pressure. This pressure is derived. It is not an independent term. It is not a fundamental word. Before knowing about the pressure, you should know about 2 words. That is force, which is also called thrust. And second one is area. So the pressure is derived from these 2 words. It is a derived quantity, we can call it as, right? Which is derived from thrust and area, or force and area. So first we'll discuss about these 2 terms. Then we'll see what is pressure, what is its applications in our day-to-day life, and what are the so many laws are there, principles, which works on the pressure, right? So before that, let us see the basic concepts over here. A very small lesson, very simple lesson. First, we'll discuss about what is thrust and what is pressure. Then we'll end with the pressure in fluids. Pressure exerted by a fluid. Fluid is nothing but liquid and gas. That we'll discuss later. But before that, we have to think about what is thrust, what is pressure, and what are the applications of pressure in our day-to-day life. Right? First, let me explain the concepts. Then we'll see some video also based on this. So first we'll start with the thrust. So thrust is nothing but force only. See, when a body is placed on a surface like this, the weight of the body acts in downward direction. So weight always acts in downward direction because of the gravitational pull. Right? Downward. And the force exerted by the body on the surface is equal to the weight of the body. Suppose when you place one book on a table, say this is a book. When you place book on a table, weight of the book acts in downward direction. Same time, the table will exert pressure on at the surface here. So exert pressure on book. But these two are equal always. Right? This is called normal force. These two are equal, then only the book will stay on the table. Right? So that is commonly for everywhere. So the body, the surface is equal to the weight of the body. The total force exerted by a body perpendicular to the surface is known as thrust. So it's nothing but force only. The total force exerted by a body perpendicular or right angle to the surface is called, see, here the force acts perpendicular like this. So the both are same. So N is equal to W. Then only book will stay on the table. If not, either book may be jump in the air or a book may be go down. So such a force which is exerting on a body perpendicularly is called thrust. Right? So note those point, very important point as a first point from here. All of you, open your notebook, write as a synopsis. First point for today. First point is the total force exerted by the body perpendicular to the surface is known as thrust. Okay, I'll draw the diagram also. You can draw the diagram in the book so that you can understand. Say this is a book, right? The weight of the body acts in downward. W is nothing but weight. And here the force acts in the upward direction, which is nothing but thrust. Perpendicular. So you are calling perpendicular 90 degrees. Right. Write the point number 1. The total force exerted by the body perpendicular to the surface is known as thrust. Is known as thrust. So it's nothing but force only. So units of the force are Newton or Dyne. Okay. So note the point and draw this diagram showing the weight in downward direction and thrust in the upward direction, which are same. Right. First point. There is one example also given to solve a problem. So point number 1 you noted, right? So before going for the pressure, we are first discuss about the thrust, because already force we discussed. Force is nothing but either pull or push. Right? The total force exerted by a body perpendicular to the surface is known as thrust. Okay. See, example is given here. Consider a rectangular block, 2 kg, that is mass is 2 kg, lying on the ground. We place 2 kg body on the ground. Okay. The thrust on the surface of the ground due to block is equal to weight of the block, that is M into G. Weight is given by formula W is equal to mg. You already seen. So what is G value is constant. M is 2. 2 into 9.8. Right. That is 19.6 Newton. So whenever there is a mass is given, you can find out the weight by multiplying with the 9.8. Mass and weight are not same. Already we discussed. Mass is different, weight is different. So when you multiply 9 into 9.8, you get the weight. Okay. Now units. Since thrust is a type of force, it is measured. It is same as that of force. SI unit of thrust is Newton. CGS unit is Dyne. Note down. So second point. Unit of thrust is Newton or Dyne. So unit of thrust is Newton in SI system and Dyne in CGS system. Okay. second point. First, we define what is thrust, then units of thrust. Right? Unit of thrust is Newton or dyne. Now we enter into our core topic, that is pressure. So before that, let us discuss about even area also. Third point, area is nothing but length into breadth. You can write length into breadth, because third point, area is nothing but length into breadth. Units are meter into meter, that is meter square, or you can write as square meter or square centimeter. Third point, because the combination of these two will give the pressure for us, right? Area, length into breadth, the space occupied, outer surface, right? So area is equal to length into breadth, that is equal to meter into meter, meter square or square meter you can write, or square centimeter. It is very small. Point number 3, thrust, units of thrust and area. Right? Right? So we'll move to our topic, pressure. So see, that is fourth point you can write. Pressure is nothing but thrust acting over unit surface. Unit of the surface is called pressure, or normal force acting per unit area. That is, pressure is equal to force by area, or thrust by area. Right? So note down fourth point. See, suppose when you are inserting nail into the wall, right? You'll keep nail like this and it will become a hammer. So what happened here? At particular area, the force will act and make the nail to insert into the wall. Correct? That is called pressure. We are putting pressure perpendicular, right angles. Then only it will go directly into wall. You can apply pressure in some other direction, it won't go. Such a force is called thrust. The force acting perpendicularly is called thrust. There are so many forces are there. Balanced force, unbalanced forces. Right? So, right on the fourth point, thrust acting over unit of the surface is called pressure, or normal force acting per unit area is called pressure. That is, so mathematical formula is force by area or thrust by area. Next, point number 5, units. Units of pressure. So force is not Newton. Newton by meter square. Right? Force by area or thrust by area. Force is Newton or thrust is Newton. Area is meter square. Or dyne per centimeter square. Or the standard unit is named after scientist Pascal. Pascal is the unit of pressure. There are so many others are there. Pascal is the name of the scientist. We can see the Pascal's law also. Okay, that is the next point. 5 point. Unit of pressure is Newton per meter square, or dyne per centimeter square, or Pascal. Right? So down given, see, mathematically pressure is normal force or thrust by area. Normal force, that is force acting perpendicularly, is called thrust. Not all forces. Only the force acting perpendicularly are called thrust. Such thrust by area is called pressure. So mathematical expression is pressure is equal to force by area. Right? Or you can write perpendicular force also, which is called thrust. Is symbol for perpendicular. Perpendicular force by area or thrust by area. So units are Newton per meter square, dyne per centimeter square, or Pascal, the standard unit of pressure. Clear? So before going for the next part of the pressure, I'll show you one video which shows very important things about the pressure and applications, right? So hope you noted all the 5 points. First about thrust, unit of thrust, area, unit of area, that is a definition of pressure, and units of pressure. See, in single page, you got 5 important points. All the points are very important. Right. So before going for anything, let me show you the video on the video on pressure. Oh, something is missing here. Just a minute. First, we'll show this.
We love Animo.
Just a minute. Just a minute. Let
We
me-
love Animo.
Did you know Terapur is an emerging neighborhood in Hyderabad?
An iron nail, you apply force on the flat side of the nail. The pointed side of the nail, which is in contact with the wall, then applies the force on the wall and tries to pierce it. Now let me
Yes,
ask you an interesting question. What will happen if you hammer the pointed side and try to pierce the flat side of the nail?
Reverse.
You will find it difficult to push the flat face of the nail through the wall even if you apply more force than you did in the first case. What is the reason for this? The reason is that the pressure applied by the tip of the nail on the wall is more than the pressure applied by the nail's flat surface. But the question is why? First, notice that the area of the tip of the nail is very less as compared to the area of its flat surface. This tells us that the area of the surface on which the force is applied matters. We will understand this in detail, but first let us define pressure. We define pressure as the perpendicular force acting on the surface of an object per unit area on which it's acting. It's easy. Force acting per unit area. We already know that the SI unit of force is Newton, denoted by N, and that of the area is meter squared. So the SI unit of pressure is Newton per meter squared. It is also called Pascal, which is denoted by PA.
Pascal.
Why is it called Pascal? It is given this name to honor the achievements of a French scientist named Blaise Pascal for his contributions in hydrostatics and hydrodynamics.
So because of his name, he developed that. The word is named. Is given a name after the scientist. Okay.
Observe the equation carefully. Area is in the denominator of the fraction. What is this area? Well, this area is nothing but the area on which force is applied. Say I keep the force constant and I keep increasing this area. What will happen to the pressure? Will the pressure increase or decrease? Use pure mathematical logic to answer this. If I have a fraction and I keep the term in the numerator constant and keep increasing the term in the denominator, then will the fraction increase or decrease? Surely it will
Inversely
decrease.
proportional, you can call it decreases.
So the pressure will decrease if I increase the area while keeping the force constant. With this newfound knowledge, let's go back to the example we saw earlier, the nail and the wall. Notice that we are also applying the force perpendicular to the surface of the wall. The angle between the nail and the wall is 90 degrees
You can
and
try
not
these both
anything
methods.
else. If you notice, the tip of the nail has a very small area compared to the flat surface of the nail, and hence the area of contact with the wall reduces to great extent in the first case. Hence, the pressure applied by the tip on the wall is greater than the pressure applied by the flat surface. That is why it is easy for the tip of the nail to penetrate through the wall. You can even use drill machines to drill the hole into the wall. You see that it has the pointed tip for the same reason. You can easily cut the vegetables using the cutting edge of the knife. But if you use the blunt edge of the knife, it will be difficult to penetrate it in. What is the reason in this case? Well, in the first sight, the two edges might look the same to us. But if you look at them carefully, the cutting edge has small triangle-like shapes with sharp outer points. The other edge has nothing of these. So if you cut a vegetable with a cutting edge, the area of contact between the vegetable and the knife is greatly reduced. Hence, more pressure is applied on the vegetables using cutting edge of the knife. Area used to cut the trees also have sharp cutting edges instead of placid ones.
See how many
It
examples they are
increases the
giving.
pressure on the tree due to the less area of contact. The examples that we've seen so far are applications of high pressure. It's about how high pressure is useful to us in some cases. But it is not always the case. There are situations where we require low pressure. Let us see some applications or advantages of low pressure. We use snowshoes to walk on snow. The reason for that is simple. Due to the larger area in contact with the snow, snowshoes reduces the pressure on the snow. We are able to walk on it without our feet sinking deep inside. In case of normal shoes, due to comparatively smaller area of contact, the pressure on snow is more and it sinks our feet deep inside. Note
See.
that the force applied on the snow in both the
You
cases
slide on
is the
the
same.
Heights,
This force is nothing but our weight on the snow. Have you ever wondered why the wheels of an army tank run on the steel tracks rather on the ground? Notice that the wheels are on steel tracks and are not touching the ground. The army tank is huge in size. If the wheels run on ground, due to less contact area with the ground, the pressure on the ground will be massive. However, the tracks have much larger area of contact with the ground and hence the pressure on the ground is reduced to a great extent. In all the examples that we have seen in this video, it is the solid which is applying pressure on another solid.
right?
To
We discuss only about the solids. Liquids will come
liquids
later.
also
Right.
apply pressure.
Okay, we'll discuss about the liquid. Before that, one more video I'll show for you. Just a minute. So, various examples are given where it is applicable for us about the pressure. How pressure is applicable for us?
Introduction.
Here, clearly given. See,
What is force?
some
What
video.
happens when a force is applied to an object? While pushing, pulling, lifting, or hitting anything, we are actually changing the motion of an object. This change in motion requires force. So we can say that a push or a pull on an object resulting in its motion is called a force. Objectives. At the end of this lesson, you'll be able to define force, list the properties of force, understand the effects of force, distinguish contact and non-contact forces, effects of pressure
total
on human
basics to-
activities. Define atmospheric pressure.
So just
What happens
basic,
when
from
force
basics to
interacts?
explain.
If you choose a heavy box and try to push it, the box will not move. Now, if you ask a friend to help in pushing it in the same direction, it moves. This experiment proves that the forces are acting in the same direction add up. Effects of force. Consider a thin rubber balloon and blow air into it. The shape changes.
This
Then
force
tie
can
its
change.
open end with a thread. Now press the air-filled balloon. You will see again the shape changes. This is due to effect of force. When you play football, the football is kept in the center of the field. When you kick it, it moves towards the given direction. Similarly, in the kitchen, your mother makes balls from dough and rolls them into chapatis. In this
Shape.
case, she is applying force to make them flat. Effects of force. One can change the direction of the object by applying suitable force on it. For example, in cricket, the speed of the ball hit by a batsman reduces to 0 when the fielder catches it. Also, if you kick a moving football, the speed of the football increases. Kinds of force. There are two major types of forces: contact forces and non-contact forces. Examples of contact forces are muscular force, force of friction, etc. Similarly, example of non-contact forces are magnetic force, gravitational force, etc. Contact forces. Can you push or lift a book lying on the table without touching it? Or can you lift a bucket of water without holding it? In both the cases, the answer is no. Generally, to apply a force on an object, our body needs to be in contact with the object. So we can say that contact forces are the forces which act on bodies when they are in actual contact. Basically, these are of two types: muscular force and force of friction. Muscular force. When we push an object such as a box or lift a bucket of water, then the force is caused by the action of muscles in our body. This force is known as muscular force.
Different types of force are there,
Muscular force
but we
is
are
always
focusing only on
applied
perpendicular
either
force.
directly through touch or indirectly with the help of a stick or piece of rope. For examples, cutting the vegetable or fruits with the help of knife, hammering of nail with the help of hammer, pulling a cart by horse. Force of friction. Do you know why a heavy box on pushing does not move? Why a rolling ball stops after some time? When an object moves in contact with another object, a force known as friction comes into play. Note that the force of friction always acts on all objects and its direction is always opposite to the direction of motion.
Opposite to the
The
direction.
moving object in the animation gradually slows down and ultimately stops due to the force of friction. This shows that force of friction always opposes the motion of one body over another body in contact. Types of non-contact forces. The types of non-contact forces are gravitational force, magnetic force, and electrostatic force. Do you know why the leaves or fruits fall to the ground when they're detached from the plant? This is because of gravitational force. The force due to Earth's attraction is called the gravitational force. This is an example of non-contact force. Now, the force between two magnetic poles placed at a suitable distance is called the magnetic force, in which like poles repel, while the unlike poles attract each other. A magnet can exert a force on another magnet without being in contact with it. So, the force exerted by a magnet is also an example of non-contact force. Do you know, when we rub a tube through dry cloth and bring it near the thread is attracted towards the tube. This is because on rubbing the tube through the dry cloth, an electrical
Electric
charge
force.
is generated on the tube.
Electrostatic
This is
force.
called the electrostatic charge. This is also an example of non-contact force. Pressure. Let us perform
Now.
an activity. Take 5 wooden boxes of almost the same size. Fill them with scrap iron to make them heavy. Arrange these boxes on a wooden table placing them side by side. See the impact of the push force from these boxes on the table. You will notice that the table remains normal and it is not affected by the push force, that is, weight of boxes upon it. Now, rearrange these boxes on the same table, placing them towards the center and one over the other. Now, see the impact.
See how
In
the
this
table is
arrangement,
bending
The table either bends
because of the
or breaks
pressure.
under the weight of boxes. Can you guess why does this happen?
Pressure.
Though the force applied in both the cases is same, but in the first case, impact is less, and in the second, the table bends. This activity proves that both the force and its coverage area are important. The smaller the area on which the force acts, greater is the impact, and this phenomenon is known as pressure. We can also say that pressure is related to the force.
Got it, na?
Daily
Very
life
clearly explained
example
about
of
that.
pressure. Have you ever
Daily
noticed
life.
that why school bags have wide straps? Why sharp knife cuts better as compared to blunt knife? And why the tip of the needle is sharp? In our
Needle.
everyday life, we all experience the impact of pressure. A school bag has wide straps so that the weight of the bag may fall over a large area of the shoulders of the child,
Pressure is it.
thus resulting in less pressure on the shoulders. And due to less pressure, it is quite comfortable to carry the heavy school bag.
Back straight.
Sharp
You see,
knife has a very thin edge. It cuts objects better because the area of contact is
area
very
less,
small.
pressure is more.
The force of our hand falls over a very small area of the object, producing a large amount of pressure. And this large amount of pressure cuts the object easily. Due to its sharp tip, the needle will put the force on a very small area of the cloth, producing a large pressure sufficient to pierce the cloth being stitched. Do liquid and gases also exert pressure like solids?
That we'll discuss.
Do you know what happens when
Okay.
you blow?
This liquid pressure and all we'll discuss in the next class. We'll continue the video in the next class to know about the pressure exerted by the liquids, right? So wonderful examples are given in both the videos to explain basically from what is force, what is thrust, what is area, what is pressure, right? These are the 5 important points we learned today along with the many examples. If you recall that, you can have see the more examples about the pressure here. So finally, you can see the mathematical formula for pressure. So pressure is equal to force by area. P is the pressure, F is the force, perpendicular force, and A is the area of contact. Note, there are some important notes are given like pressure is directly proportional to thrust. So you can write pressure is directly proportional to thrust or force. Pressure is inversely proportional to area. These are the 2 equations from which we can get from here. Means when area increases, pressure decreases. But when force increases, pressure increases. When area decreases, pressure also decreases. The inversely increases. That's what nailing and needle, bag, every example is showing that what happened when area changes to the pressure. Right? So given units, Newton per meter square, dyne per centimeter square, or a Pascal standard unit named after the scientist. Okay. Blaise Pascal. One unit measured in bar also. 1 bar is nothing but 10 power 5 pascals. That we learn when you learn about the atmospheric pressure. Next topic. So before that, there is applications also there. In next class, we'll discuss in deep about the applications of pressure and all. Right. So far we discussed about what is thrust, what is area, what is pressure, and what are the units of thrust and pressure. Okay. So many things to learn. In the synopsis 2, we learn about what is the fluid pressure. Pressure of the fluids are there, and laws are there, some laws, and what is atmospheric pressure. Pressure exerted by atmosphere. So 2 more classes you will take to complete the chapter. Here there are different types of pressures. Pressure by solid, pressure by liquid. Okay. By end of the chapter, we can learn everything about the pressures. Right? So it's a time for the home task, homework. Note on the question, define thrust and pressure. Define thrust and pressure. So what we learned today already mentioned in the synopsis. Write it in your notebook and show to your teachers and parents. Take the signature. Right. So that's all for today. Thank you all of you. Have a wonderful day. Thank you.